Okay, today we need to talk about significant figures and how we work with significant figures. And so this is a PowerPoint presentation with some other practice as well. And the rules for counting significant figures, we've been over these before in class, but we'll go through them once again here so that you can take a look at them. Counting numbers have unlimited significance. All non-zero digits are significant. Zeros between non-zero digits are significant. And when a decimal point is present, go to the first non-zero digit and count it and all digits after as significant. And in exponential notation, every digit before the multiplication sign is also significant. And you should be pretty good at counting these. This is just a quick refresher so that when we start to do the calculations that you'll remember them. And you can go back and take a look at this if you need to. Calculations. There are two different sets of rules for calculations. There are sets for addition and for subtraction. The rules for addition are to write the problem, lining up the decimal points, add, subtract, and write down the total, and then chop the answer to the least number of decimal places, shortest number of decimal places, and round it. So when we take a look at these numbers here on the chart, we have 35.45 grams and 33.2 grams. Now, most of the time, when you're adding or subtracting numbers in a science class, those numbers are going to be in the same unit, just measured with different measuring devices, and maybe they don't come out the same length. Most of the time they will, because you'll be using the same measuring device. Our balances go to 2 decimal places, so most of what we do are going to look like this, like the first one. But suppose we used a different balance, we would get one like the second one that doesn't have as many significant figures. We added the numbers up once we lined them up, and then to decide where to round it, this is what we mean by chop. We start and we cut off at the least number of decimal places. And that means that the 5 here is not going to count as a significant place, so we have to round it if necessary. And in general, 5 and up, you round up, and that's how we went from 68.65 to our final answer of 68.7 grams. That's how we work with addition and subtraction problems in significant figures. Multiplication and division is a different set of rules. You write down the problem, count the significant figures in each measured value, and counting numbers like 3 people, that 3 has unlimited significance. So you don't have to call it 1. It's completely significant because you can't have 0.2 people, is what the argument is. Once we've counted the significant figures, we do what the problem calls for, either multiply or divide. You round the answer to the smallest number of significant figures in the measured values used to calculate it, and that's how you finish the problem. Now, if we take a look at this case here, in this first number, we have 3 significant digits. The 6, the 8, and the 7 are all significant. And in the second number down here, the 3 and the 2 are significant. So we wrote 3 significant figures up here, 2 significant figures up here. You don't necessarily need to write those down. It just helps you to keep track of what it is that you're learning. Okay? When we go ahead and divide these numbers on the calculator, we get a tremendous number of decimal places. Now remember, these are measured values, grams and milliliters. Did we measure them to all of these decimal places? The answer is no. And we can't get more accurate just because our division doesn't come out evenly. We have to chop it off to a shorter number of places, and we do that by limiting it to the least number of significant figures that we had to start with. We had 3 significant figures for our numerator, but only 2 in the denominator, so our answer is only going to be allowed to have 2 significant figures. And so we take a look at our number here, and we're going to have to round it off to just the two significant figures, which means it gets rounded off to 21 grams per milliliter. And this is our final answer with the appropriate units. So the rules are very different for multiplication and division than they are for addition and subtraction, but they do follow and make sense based on what we measured. In a series of calculations, carry out the calculations and then round to the most limited intermediate result or measured value. So the least number of significant places that you measured is going to be the number of significant figures that your answer is going to have. The big idea, you can't get more accurate than what you measured. Thanks and enjoy. We'll do some practice problems in the next series.